Welcome to the second week of the conference and the first session in the MQ stream. This is session 1AU, so please enter that on your feedback form after Matt has done his bit. And welcome back, Matt, who's talking about where's my message on zOS. Over to you, Matt.
Thank you. Okay, so good afternoon, just about. My name is Matt Lemming. I'm the architect for MQ for zOS, normally based at Hursley in the south of the UK. So today we're going to be looking at where is my message on zOS. So this is a zOS-centric presentation, but some of the things I'll be talking about are actually cross-platform, so they're common to MQ and distributed as well. What we know is that customers have widely deployed MQ around their environments, and they run MQ on-prem, in the cloud, and some customers have vast deployments with thousands of queue managers routing data around the world. And we see customers are now hitting points where they don't just send millions and billions of messages a day. They send trillions of messages a day. So there's lots and lots of data in the form of messages moving around MQ, and that means it's inevitable at some point data isn't going to route where you think it should have done, right? Okay, you'll send an a message into your MQ network, and it won't quite get to wherever it should be. Now, in most cases, that doesn't mean you've lost a message. It just means it's gone somewhere unexpected, or something like an application has received it and perhaps not done what it should have done with it. But basically, the bottom line is every so often something goes wrong somewhere, and then you need to try and understand what it is that went wrong, how that happened, and how to rectify it. And that's really what this presentation is all about, looking at the tools that are available with MQ on zOS to figure out what went wrong when messaging, so you can kind of understand how to fix it and move on, and hopefully you won't lose your message again. And this isn't a presentation that says we spend all our time losing messages. That's not what's happened here at all, but it does happen occasionally, and normally there's a good reason. Normally the message is still there somewhere. The question is, where is it? And that's an easy question to answer when you've got one queue manager, but for those big networks, big production deployments, it becomes much trickier. So we're going to look at a number of different aspects to the where is my message question, because we've kind of got, there's a wide variety of tools basically in MQ to kind of answer this sort of challenge. And so the first thing is actually understanding what's connected to your MQ network, because once you understand what's connected to your MQ network, you can start to figure out if that's the right set of things. If your messages are not being processed in a timely fashion, does that mean that the thing that's meant to consume them isn't actually connected to go and get messages? Or if messages aren't turning up in MQ, maybe they're just not being sent. The next aspect of that is, if your applications are connected to MQ, are the messages moving through your system in the way you expect? And are they going where you think they are? Because if they end up going to a different queue manager and you're looking at a queue manager over here when you should be looking on a queue manager over here, then that's obviously a thing that can happen, and so you need a way of trying to figure out whether that's a possibility. There's also the question about, well, if I can understand how my messages are routing through MQ and they seem to generally be doing the right thing, but every so often something goes wrong, what are my apps doing? Are they doing the right thing all the time, and how can I spot that? And then lastly, at the end, we're going to talk about a bit of archaeology. Can I go back in time and understand what happened when my system, something went wrong in my system in the middle of the night last Tuesday, for example? And so we're going to look at all of that and a variety of tools. And just to reiterate, lots of the stuff I'm going to talk about is common and cross-platform, but there are differences. And in some cases, the differences are just in form. You know, the same capability, or broadly the same capability, exists on MQ for zOS and MQ for distributed. In some cases, actually, there's not the same solution, or maybe you've got a solution on Z, but you haven't got it distributed. So there's a bit of variation here. But certainly, the first few topics I'm going to talk about are actually entirely cross-platform, and it's always quite interesting. So a lot of the things I'm talking about here are actually, in fact, all of the things I'm talking about here have been part of the product for a long, long time, okay? So this isn't necessarily brand new stuff I'm talking about, but it does always surprise me how few people are aware of all of the capabilities. And I think that's what shows you that actually, you know, messages tend not to go missing, but when they do, it's useful to have a bit of a leg up to how to go and spot what's going wrong, and that's what this presentation does. Anyway, let's start with what's connected. So here, you know, what you really want to understand is what applications are connecting into my queue manager, and where are they connecting from, and what queues are they using. So here, the display con MQSC command is your friend. So, you know, this is definitely one to have in your toolbox, basically you can go and see what applications are connected into a queue manager. And there's basically two forms of display con. One is to get a view of what queues or other resources connections interacting with. And then there's also a way of looking at the connection itself and understanding the attributes of that connection. And I think really it kind of depends which set of problems you're trying to solve first. So the approach that the presentation takes is that actually you're trying to focus in on a particular you know, application queue that something is wrong with for some reason. So what we actually want to do is we want to say, show me all connections into this queue manager where that connection has opened a particular queue. In this case, it's the WLM mdb.request queue, because actually this is a WebSphere application server application. So when you run that command, it will basically spit out a list of all of the connections that have connected to that queue. And that's kind of the top half of this page. So once you've got that information, you can kind of go and look at it and see if it matches what you expect. So here we see we've got a connection, and there's this sort of hex string that represents that connection. And that's an important string because it allows you to piece together the different bits of the puzzle. And there are several bits of the puzzle here. And then you can actually go and see that this connection, which objects has it opened? So, you know, we know it's going to have opened this request queue, and we can see it's opening it for output. So that means it's going to be writing to that queue. So it's obviously sending, you know, request messages in some form. And we can also see that actually it's also got a handle open on the reply queue. So we can guess that this is sending messages, request messages, and then waiting for a response to come back in and doing something with it. And so you can kind of, you know, use this. And if there's nothing with that queue open, that's obviously probably part of the problem you're trying to solve. But if there is something there, then you kind of need to start to understand, well, you know, where is that application connected in from? Is it where I expected? Is there the set of those applications connecting in that I expect? And so now that we found the things that are using that queue, let's go and find out what those actual applications are. And so to do that, we again use the display con command, but now we want to actually understand more about how the application is connecting in. So this is the bottom half of the slide. So, you know, again, this con field ties these together. So we use here, when we want to find out about a particular application, we provide the connection ID in the display con MQSC command. So here, now we get lots more information. And we can actually start to see that, you know, this is a client application that's coming in over the network. And we can tell that because down the bottom, you can see, well, not see very well, that there's an Apple type of Chinit and there's a channel. So now we understand that there's a WebSphere application server connecting into our queue manager over the network. And actually, we can see where it's come in from. So the con name field allows us to see that actually it's coming in from the local host. Now, if you can imagine, you've got lots of connections coming in. You can now use this information to try and to kind of look back a level and actually go and identify the machines that are coming in, and perhaps go and look at the applications running on those machines and to see whether they are are a particular problem. Another, and so, a key part here is actually understanding where does that application run. And that's the kind of the detail at the bottom. Another useful set of information is actually what's going on from a transactional perspective. So many times in the past, we've seen problems where customers are like, well, my messages aren't flowing. And it turns out they're sending these messages, but they aren't committing the transaction that the messages should be sent under. So while they're being put to the queue, and the messages, the cur depth and the queue is building up, they're never pressing the commit button, or they're not pressing it enough, which means that the message is never properly getting sent. So there's a useful set of information here that actually shows you when the unit of work started. So you've got the unit of work start time and the unit of work start date. And if messages aren't coming in, and you have a unit of work that started some period of time in the past, an appreciable period of time in the past, and you go and look at your queue and actually find it's got loads of uncommitted messages on it, it could well be that the messages are being sent, but for some application flaw reason, they're not being committed. And actually, now you need to go and look at your application code and understand why they're not being committed. So that's quite a common thing. Certainly if you're developing applications, it's not something you tend to see in production so much, but it's often something that turns up in developing, and sometimes it may turn up in production, but it's probably a rare case where you're kind of going down a path of your code you don't normally expect to go. So that unit of work start time, unit of work start date, and also the fact that you can tie your connections up and the current unit of work with something like WAS, which is what this external URID field thing here means, is also quite a useful thing, because you can kind of see the WAS view of the things as well. So now we know that there's a connection coming in from WAS, and we know it's coming in over the network as a client. So we can kind of go an extra level of detail in. So here, what we can actually go and do is go and look at the channel status for that client, and that allows us to see what is the current state of that channel. So it's a real-time view of what's going on. So display channel status command helps us with that. We can put the channel name in, which we know from the previous command. So you can do display channel status was.clients, even though that's not what the slide shows. And then you can actually start to kind of look in here in a bit more detail, and perhaps pick together some more parts of the puzzle. So if you've got lots and lots of different clients connecting in, then obviously, again, the connection name points you to a particular physical host, but maybe the certificate information identifies a particular client running on the host. So down the bottom, this SSL peer thing allows you to see the exact certificate used by that application connecting in, which might be helpful if you want to really narrow down exactly what's connecting in. And actually there's other useful things here as well. So we've got this R product and R version field. So the R product shows you that what type of thing is connecting in, and MQJM is basically an MQJMS application, and there's a range of different values can be in that field, and then you can understand whether it's a C application, a Java application, an AMQP application, all those sorts of things. And similarly, the R version field allows you to really understand what version of client it is. So in this case, it's a 912 client, because I originally wrote these slides like a year and a half or so ago. Other useful information is actually when this client last did some stuff. Okay, so understanding when the channel started and start date is always a useful thing. That's these two fields here. So if someone's complaining that their data hasn't come in, but they sent it yesterday, if you can see that the channel only started today, that tells you something. That tells you that maybe they didn't start that channel when they think they did, or maybe it just was running yesterday and then it failed and it had to restart. So it just gives you some possibilities rather than guarantees here. And a similar thing here is when was a message last transmitted over this channel. That's where the last message time and last message date, and also the messages field gives you some extra information that you can use to kind of help piece together this puzzle. And I should say that, you know, I've obviously got all this information in these slides. This sort of approach to diagnosing what's going on and a bit of forensics is also documented in the Knowledge Centre in terms of steps you can take. So, you know, that's one set of things. I'm now going to have a bit of a diversion, which is actually, you know, what we've been looking at is how do you understand what's connected and how long have they been connected and what are they sending? But actually, often there's a need to reroute messages if no one's currently connected. And so this is a little bit of a diversion on this presentation, I think, but it's a useful one nonetheless. And so we're going to spend a little bit of time, just a few slides, talking about clustering. And because, you know, many customers use clustering to route messages around their MQ network. It provides a very nice, easy way of setting up a large set of queue managers without having to wire them all together. But it is not uncommon for customers to forget that with an MQ cluster, you basically need to make sure that whenever you have a clustered queue, that you always have something sitting there to actually process the messages on the queue, okay? And that's something to always bear in mind with MQ. So if you've got a clustered queue where you have multiple copies of that queue on a set of queue managers and you're spreading messages between them, then you typically want to make sure that there's almost always something there sitting there to consume those messages, because if there's nothing there to consume them, then the messages will build up, and that's probably a bad thing, okay? And you know, in the past, and actually by default today, MQ doesn't do anything if there's no application sitting there consuming from a cluster queue, okay? So it's your responsibility to make sure that in this case, we've kind of got these target queue managers down the bottom, and we've got a set of applications or a set of application queues, which are kind of the highlighted things down the bottom. And you need to have an app server, in this case, sitting there on this queue manager, and also queue manager 2, where there actually is an application server running. And the problem with this picture is that actually there's nothing here on the target queue manager 1, and there's nothing consuming from target queue manager 2. So messages are now going to build up. And you know, maybe that's fine, maybe that's deliberate, but actually in many cases it's because something's resulted in the processing application, the application server failing, and you need to think about restarting it, you know, via automation or alerting or whatever. But actually, there is something else you can do here. As well as having that alerting in place to restart the consuming application, there's something else you can do as a fallback plan for actually preventing clusters or messages building up in cluster queues. And that's this snappily titled AMQS CLM, which is basically an application we provide that provides a whole load of monitoring and routing capabilities for MQ clusters. So here's the basic vision, okay? So we've got a set of applications sending into a cluster, and those messages that are being sent by the applications are being spread across a set of back-end target queue managers. And what you normally want to do is have all of those clustered queues and the target queue managers have something sitting there processing them. And in this case, we've got an app server processing those queues. So that's normal, okay? That's what normal should look like. And in most of the cases, those queues are going to have nothing on them, no messages at all, because whenever a message turns up, it gets processed straight away. So that's the desirable state. And you'll notice we also here have this AMQS CLM application sitting there on each queue manager, monitoring the state of the cluster and being ready to deal with, you know, adjust the cluster if anything changes. The other thing that's worth pointing out is because we've got an application server consuming from these queues, the IP procs, which is the number of applications with the queue open for input, i.e. reading from the queue, is greater than 1. So that IP procs value tells you that there is something consuming from that queue. Okay, and that's kind of an important bit of evidence because it's what's used by AMQS CLM. Okay, so you know, if we now move away from the stable steady state, something's caused app server 1 to fail. Okay, so you know, maybe there's been a hardware outage or something like that, and so the application server goes down, and that means there's no one now consuming from the cluster queue on target queue manager 1. And because there's nothing consuming, that means the IP prox for that queue manager now goes down to 0 because there's no processes consuming from that queue. However, messages are still being sent via the sending application, and the MQ clustering workload management algorithm doesn't care whether anyone's sitting there consuming messages. It just keeps routing the messages in, okay, and it round robins them amongst the available queue managers by default anyway, okay. So it keeps sending them in and it will round robin them, which means some of those messages are going to go to target queue manager 1. They're going to sit on that queue, and because there's nothing there to actually process them, the queue is going to start building up. And that's okay for short periods of time, but for longer periods of time, or when those messages need to be processed quick, that's definitely a bad thing. So here's where AMQS CLM comes in. So AMQS CLM will monitor the set of queues that it's been associated with. So it looks at the cluster queues, and by default, it does it every 5 minutes, although you can change that. And it detects that nothing's sitting there consuming messages from that queue. And that's obviously a problem, okay? And the reason it does it every 5 minutes is it gives it enough time for that app server to restart. So if there was a transient failure, the app server goes down and comes back up again, that would be fine. In this case, it's a long-running failure, and so action is needed. And the AMQS CLM basically does that. What it does is, because the app server's down, it adjusts the priority of the queue on target queue manager 1 to reduce its clustering priority. And what that means is that queue is no longer of interest, or is no longer sent messages by the clustering workload management routine. So the applications up top sending messages in now won't get messages sent to that target queue manager 1. Instead, they'll get sent to the target queue manager 2 to N, because they've got something consuming those messages. So this is good news. We no longer are building up the queue on target queue manager 1. So that's great. But what we do still have is a backup of a set of messages there that are kind of stale. They're kind of getting older and older as time ticks on. And so another option you've got with AMQS CLM is also to redistribute those messages. You can enable that if you want. And what happens then is the AMQS CLM application will basically consume those messages from the queue and then send them back into the cluster. And again, cluster workload management ensures that the messages get sent to the other queue managers and the other queues in the cluster. So now you've gone away from the situation where your messages are getting stale and they're able to be processed by the remaining app servers in the cluster. And like I say, in an ideal world, you'd have restarted the app server immediately, but sometimes that doesn't happen, and AMQS CLM is a really useful backstop. Okay, so this is a sample application we provide, and it's shipped with the distributed product as a sample. We don't actually ship it on zOS, but you can take it and you can run it against zOS, and it's fully supported. So if you are in the sort of environment where this is relevant, then just bear in mind this entirely is supported in zOS. So, moving on again, sort of back perhaps more to the monitoring side of things, let's start looking at the next set of things. We know applications are connected into our queue managers, but actually are messages being moved through them? Are those applications sending messages? And there's kind of two views to this. There's a real-time view, and then there's a historical view. Both of those things have value. And we're going to start off with a real-time side of things. And so real-time with MQ basically means you can run MQSC commands to see the state of your queue manager. And it's, again, not that dissimilar to what we were looking at a few slides ago. And there's two sets of real-time monitoring. First off, we're going to talk about queues. So I should say, by default, real-time monitoring is not on. Okay, so that means if you want to go and use this today, then you're going to have to switch it on. We would heavily recommend that customers actually enable this by default, because it is so useful understanding what's going on with your queues. Everyone cares about their queues. They care about their queue depth getting high, and you get that regardless of whether real-time monitoring is on or not. But all the things in a lot of the things on here, other than the OP procs, the IP procs, and the cur depth, are things you have to enable. And basically, if you haven't got them on, you should. You can tick them all on by basically setting a queue manager switch, which says enable queue monitoring, and that's the command at the top here, auto queue manager mon queue high. It has a high, medium, low value on zOS. It doesn't matter. Just call it high. It doesn't matter what it is. And also the cost of doing this is pretty low. Okay, it's not something you're going to suddenly run out of CPU for, but it is incredibly useful if you want to try and understand what's going on with MQ. So switch it on by default. So let's look at what we've actually got. Now we've kind of, the thing that's always a really good thing to look at is cur depth. How many messages on my queue? Okay, and you get that, that's always available. You don't have to switch real-time monitoring on. It's also useful to understand what, if anything, is sending messages in to that queue, which is the OP procs, and then there's the IP procs, is what is reading messages from that queue. And we kind of covered those on the previous slides, but again, bear in mind that this is a different view of the same of related data. Another key thing here, and again, this goes back to what I was saying earlier about transactions, is if your messages aren't appearing on your queue, but your application thinks it sent them, could it be because they've been sent but not committed? Okay, those messages will be physically on the queue, but until they're committed, no one can go and get them. And so if you've got uncommitted messages on the queue and this uncomma attribute says yes, that's a potential thing to go and investigate. Are those uncommitted messages the ones that you're expecting to have been committed 5 minutes ago? If yes, then you've probably got an application glitch to look at. Other really useful things in terms of understanding whether your queue's being processed in a timely manner is the queue time. So the queue time basically allows you to see what's the average amount of time that messages are sitting on the queue waiting for being processed. And this is microseconds, okay? So it's a long number, and there's two of them. And we'll see that there's a number of these attributes where there's actually two different values. So the first value is like a short term average, and the second value is a longer term average, okay? So, they're both useful. And if you see the short term and the long term average deviating from each other significantly, then that might be a clue that actually, something's changed suddenly just about now, okay? Like if the queue time is normally small from a long term average and the short term average has got a much larger queue time, that's probably a bad sign, because it means messages are now sitting on the queue longer than normal, and that's probably a recent change, so you need to understand that. And this particular set of numbers, we can see that actually messages are spending about 10 seconds on the queue. That may or may not be a problem. It does depend on your application. So again, as well as having this data, it's also useful to have look at it occasionally and understand what the normal values are. Is it normal for messages to spend 10 seconds on the queue before being processed? Maybe it is, maybe it isn't. But you understanding that is important. Message age, this is another interesting one, and it basically shows you the oldest message on the queue. Now this can be quite useful, particularly if you've got like the odd marooned message that's been stuck on the queue for ages and no one's gone and got it. And maybe that's an application bug, or maybe that message should be expired in some way. So should you actually be using message expiry for the messages on your queue? Because really, you don't want messages to be sitting on the queue for a long period of time. And if they're no longer going to be processed, then either you need a way of clearing them off, or you need to think about putting, when you send a message to that queue, you need to have it with an expiry defined by the putting application, or maybe you can use the cap expiry function that's in queue now. And then the last set of attributes here, last put time, last put date, last get time, last get date. Obviously that's telling you who used that queue to put to, or use that queue to get from last, and that's kind of a useful thing. If all of the puts are, well, the last put time is now, but the last get time is quite a long time ago, that implies that your queue depth is likely to build up. And why is if something's connected but not getting, why is that? Okay, so just another clue and another piece of the puzzle that you can consider. What I should say is, given that we're talking about MQ for zOS here, these attributes have slight differences if you're looking at shared queues. Okay, so for shared queues, you get a queue manager's view of what's going on. Okay, so when you look at a shared queue, because obviously that queue is being used by multiple queue managers in the queue sharing group, you'll see the same cur depth across those queue managers, but things like IP procs and OP procs and last put time, last get time is that local queue manager's view. Okay, so if it is a shared queue, go and look across the whole queue sharing group to get a complete view. And that's, you can tell that by whether the QSG disk down the bottom is queue manager or shared. Okay, so we talked about real-time monitoring for queues. You can also have real-time monitoring for channels, and we kind of looked at that a little bit earlier. And again, the same sort of thing applies here. It's not on by default. We would definitely recommend you consider it switching it on across your queue managers, because this is useful information that you should really start to understand and be able to look at when you want it, rather than having to go and switch it on and wait for it to be enabled and all that sort of stuff. Again, it has this idea of high, medium, and low. That doesn't matter on zOS, whether it's high or low makes no difference. There is a bit more of a cost with this, and that's detailed in the MQ, one of the performance reports. However, it is really valuable information because it allows you to understand what's going wrong, and you want to have it on really. So what information have we got here? So here's an example for a particular channel. So you can now see when that channel started last. Actually, I'm looking at the wrong one. Where's the start time? Yeah, so channel start time and start date. So again, that's obviously a useful one. Does that match up with the problem you're seeing, or is it after, which might explain some things? When was the last message sent over the channel? Again, does that is that a long time ago? That's probably a bad sign. Or was it more recent, in which case maybe it's not that important? And there's a couple of useful attributes here for, again, this short-term and long-term averages. How long a message is spending on the transmission queue if this is a sending channel. This is really useful if actually messages are being sent but they're not getting where you expect in a reasonable period of time. Maybe that's because something's slowing down the consumption of those messages, and so actually they're spending a long time sitting on the transmission queue. And again, this is short-term, long-time averages. So that's a useful thing to be aware of. And sometimes actually it's not so much an MQ thing that's slowing things down, or an application thing that's slowing things down. It's actually your network. And so there's lots of things you can do to look at the network side of things. A lot of those are kind of outside the MQ area, but one thing you can do is look at the net time. And this is, again, for sender receiver channels. Net time is basically the amount of time it takes at the network layer to complete a batch confirmation. So when you're sending messages over sender receiver channels, they get sent in batches, and at the end of the batch, you basically, or MQ kind of goes and makes sure that the messages have been received on the receiving side, and it sends this batch completion flow. And when it does that, it basically gets data that allows it to figure out that there's a time spent from sending that completion flow to it being received at the other side, and then there's a time spent from having a response sent back. And it's those two network timings that go into calculating this net time attribute. So it's the round trip network time of sending that batch commit flow. And again, if that's large or changed, maybe that's something to look at. Maybe your network has had a sudden glitch for some reason. And there's loads of other useful stuff in here as well, like the version information I was talking about earlier, the R product and R version. And there's also information like, if you're sending messages and normally you're sending them in batches, and that means it's a nice efficient way of sending messages. You send 50 messages, commit that, then actually that is a more efficient way of doing messaging than if you were sending one message at a time. And again, maybe that's changed. Maybe it used to be that you're sending batches of 50 messages and now something's slowed down or changed, and now you're sending single message batches, and that means your throughput's gone down. So again, you can look at the X batch size, which is the average. You can look at the configured batch size, and you've also got this cur messages, which is the current batch size as well. So, you know, this is real-time monitoring. So this is something you can go and look at any point you want and kind of build up a picture of what's normal for your system. So if something goes wrong, you'd start, you know, running the display queue status, display channel status command. And that's great, but there will be times where you want to look in back in time a little bit. And so here we move away from commands and we actually start looking at SMF data. So this is an area where it's different on zOS. Sorry, on between zOS and distributed. So zOS, if you want to understand what's historically happening to your queue manager, then we generate data in the form of SMF records. And there's basically two types of SMF data. There's SMF 115 data, which is high-level statistics across the whole queue manager level, okay? So that allows you to see what is this queue manager been doing on aggregate, like, you know, how many messages are coming in, how many messages are going out, how are my buffer pools performing, how's my log performing, and things like that. And, you know, taking those statistics and doing something with them and understanding what's normal for your environment is really, really important when you're trying to understand performance problems. It can also be important when you're trying to understand where is my message, because sometimes a performance problem is the result of your message going not getting to where it should be. I should say, if it's literally a case of a single message going, you know, to the wrong place, the statistics level information is probably not so useful because it's kind of aggregated up at the queue manager level. So you can see the number of messages coming in and the number of messages going out, but that's at the whole queue manager level. We do have a statement of direction saying that we're going to start providing statistics at the individual queue data. So the sort of stuff we saw for display queue status, but at the queue level as an SMF 115 record. So that's coming, okay, some point in the future. What perhaps is more useful to understand really what's going on at the application level is the accounting data. This is the SMF 116 record. So this is way, way more detailed, okay? There's lots of it. And it allows you to understand what's going on from an individual application level. What's that application doing with, in terms of hitting the MQ log, how much CPU is it using? And it also has information about MQI, number of messages put, number of messages received. And it also gives you, more detailed information around your queues and your channels. The challenge with it is that it can be quite a lot of data. So you kind of have to, recognize that it has more expense than statistics data. That's not saying it's really expensive, it just has more expense and it requires a bit more experience to interpret. However, we do have tools for it. But I think this is often a bit more of a speciality skill, although we do have customers who really know this stuff really, really well. So enabling this function, so again, stats and accounting SMF data isn't on by default. You have to switch it on. And for statistics, it's basically switch it on and then you start getting the data because it's generated throughout the queue manager. And if you want to have accounting data, that's something you switch on probably on a bit more of a fine-grained level. So you go and say, I want it for this set of queues and this set of channels. But either way, once you've switched it on, then the queue manager is generating this data and it will generate it periodically, and that's what this stat time attribute up the top right is. And that can be today, it can be every from 1 minute to every once a day. The default is normally around half an hour. So commonly we'll see customers getting this data at half an hour, and that may or may not be useful depending on what you're trying to debug and track down. And so, it's something you might want to make more frequent. It kind of depends what you're trying to do. But anyway, once you've got this data and it's being dumped out to SMF, you then need to take that data from SMF, which is done by running a set of commands, and that data will then be dumped to a data set, or there's other mechanisms to consume it as well. And then you run it through something that actually does something with the data. And so we provide a set of utilities for that as samples. So we've got CSQ4 SMFD, which is a sample C program that takes this data and formats it out. But it is very basic, so you see the data, but then you have to understand what it means. We have MP1B, which I'll come back to in a minute, which is a support pack which actually understands the data and does more useful stuff with it. And increasingly, we're seeing customers actually taking this data, splitting it into comma-separated records, and then sticking it into Splunk or spreadsheets or databases where you can do queries. And so that's what this attribute is, this option is here. And again, you can just go and download that and use it to your heart's content. We also have products that do this. Some of these are provided by other companies. IBM provides a Megamon for messaging, which gives you is a great monitoring tool that provides you both historical monitoring and real-time monitoring. So it provides both the stuff we were looking at the beginning and the stuff we're talking about now. And a new part here, a new thing, is IBM Z Anomaly Analytics. This is a product which used to be known as IBM zOA. It's now called zAA. And basically what this will do, and this is new from September, is it will take the MQ SMF 115 data, so our statistics, and then it will use machine learning to build up a model of what's normal for a particular queue manager. Okay, and once you've got a model of what's normal, it will then kind of move into scoring mode, where basically it consumes real-time SMF data from the queue manager, and then it looks for deviations from normal. So if normally you have this number of messages coming in over time, and suddenly that message rate halves or doubles, then if that's a significant enough deviation, it will spot that, it will show it on a graph, and it will generate an alert, and you can go and do something about it. So it's a nice, powerful tool. And of course, you can write that sort of functionality yourself. And we've had customers do that as well. So let's talk about MP1B for a minute. This is kind of used by lots and lots of customers. It is an unsupported support pack. It was written by the MQ development team as a result of lots of engagements with customers. So, it knows what the SMF data looks like. It is kept current with the most recent formats of the data, and it can be used to pull out the most important information and give you some advice. Okay, and there's lots and lots of things you can do with it, which are written down here. So this is, if you want to start looking at this data and you've not looked at it before, or you've looked at it before but not known what to do with it, then MP1B is a great getting started point. I think it kind of, I think it's great for getting started, and it actually probably gets you quite close, even if you're a power user. There are things where actually you kind of need to go to the next level and maybe get the data in a database, but this is actually good for many customers. Okay, what it isn't is something like zAA or a Megamon, which is more of a long-term tool for seeing what's going on. This is kind of, I want to understand what's going on now, or what happened last week. I'm going to have a poke around, but it's not, it's very useful, but it's not got the same level of capabilities as the proper products. So some examples here. This is just basically, showing some data coming out of my queue manager and allowing you to see what's going on across the set of queues. Like I said, this sort of data is perhaps less useful if you're trying to find an individual message going wrong, but if you've got more of a systemic problem, it's more useful. And actually, if you want to go down into the per application view, this is what the sort of stuff you get out of MP1B. So you can see that actually this is an individual application coming in over the system.def.servercon into zOS, and we can now see what that application was doing. So it sent some messages, it got, we can see that it did put 100 messages to AQ and then got 100 messages off it. And you can see how long that took in terms of CPU time. And you can see there's also things like backout count. So that means that the messages at some point were sent and then backed out. Again, that might be a useful clue. So lots of data here. If you have the SMF116 records on. And then we also have channel accounting data. So this is very similar to display channel status I mentioned earlier, and just allows you to have a historical view of it and actually get that out without using something like a Megamon or having a regular capture of display channel status. So one thing that always comes up when we're looking at SMF data, and I kind of alluded to this, is that actually collecting SMF data has a cost. There's both the CPU in terms of what the queue manager uses and the storage of the records. So yes, there is a cost. However, you've got to think about the benefits. So the 115 data, which is the stats, that is basically close to zero cost. Always have it on because it's so useful if you need to use it. Accounting data is a bit more significant, and that is with the order of 1 to 3%, depending on exactly what's going on. And this is really based on what we've seen in our performance tests, which might vary quite significantly from what you see in your environment. And lots of customers get scared about this 1 to 3%. The thing is, you need to bear in mind that if you don't have this data, it is often really, really hard to understand what's going on. So when sizing a system, try and bear in mind it's useful to have headroom so that, fair enough, you don't have this accounting data on all the time, but you do need to have the ability to switch it on if you do have a performance problem, because that's how you figure out what your performance problem is in most cases. And we do have customers, this is the, one of the lower bullet points. We've got customers who run their environments so close to the edge that when they see a performance problem, the act of switching on the accounting data pushes them over the edge, and then they can't understand what their performance problem is. So, allowing for this in advance and sizing for it in advance, even if you don't have it switched on, is actually quite a useful thing, because it means that, fair enough, don't blend the CPU most of the time, but if something does go wrong, have the headroom so you can switch it on. And also, understand what's normal. Don't just look at this when something goes wrong. Look at it occasionally when things are just normal. Understand your baselines. Really, really important. So 13 minutes left. So I'm just going to maybe speed up just a little bit on the last couple of topics, because I've been waffling. Okay, so MQ networks can be, can be complicated. Okay, some customers might just have a small handful of queue managers, but lots and lots of our customers, because they use MQ so widely to communicate across their whole application ecosystem, they might have thousands of queue managers, okay? And that means understand where your messages are going is a challenge. And up to now, we've kind of looked at individual queue managers. What do you do if a message gets sent and gets lost on the way? How do you understand where that message could have gone? Okay, you know where it should go. Where could it have gone? And so, here we have a simple picture at the top. We've got 4 queue managers, and we want to send a message from app 1 to app 2, and then send a reply back. And basically, each of those red dots on the picture at the top is a point where a message gets temporarily staged onto a queue. And then the lines between the red dots are the channels. And so there's the potential for those whenever those channels are in place, for messages to get sent to the wrong place, or get sent to a dead letter queue, or go to a different queue manager to what you expected. And we're not saying here that messages are lost. It's more likely that messages are on a DL queue or stuck on a transmission queue when a channel's trying to reconnect to a queue manager that's gone down. Okay, and understanding where that point is absolutely something you can do manually by going and looking at everything that you think is likely to be in the path. Go and look at the channels on the path to the queue manager that you think is the back end environment. But that can be hard if you've got a large set of queue managers and reaching, lots and lots of hops for your messages. So actually, there's a tool that you can use to speed this process up, and that's called traceroute. And the idea of traceroute is that it's a bit like with like if you go and see a film where they're firing a gun, every so often you'll end up with a coloured tracer bullet going out that actually allows you to see where you're firing. And the same idea applies with MQ. It's possible to inject traceroute messages that aren't real messages. They're just things that look like a real message, and they get sent through the system and then get to the endpoint where they're hidden from the application. And the valuable thing about Traceroute is they send back something called an activity report that allows you to see where they've gone. So it shows I've been here, I've been here, I've been here. And then if they suddenly disappear, you know where they last got to because you can see the last record in the activity report. And that means that something around that area is where they've got lost. So if you've got 10 queue managers and it kind of got to through the first 6, then that means you don't have to look at those first 6 queue managers. You can kind of go on the boundary between that 6th and the 7th queue manager and understand where the message might have got to. Now, they're not, Traceroute messages aren't perfect. It's just showing you where the messages could have gone rather than exactly where they did go. But it's a useful way of getting close to understand what's going on. And certainly, if you send a number of Traceroute messages and they all disappear at the same point, that's quite a clear, indication that something's going wrong at that level. So in order to send these things in to MQ on zOS, then we don't provide, so MQ for zOS supports Traceroute messages, but we don't provide a tool to send them in. However, there is a command line tool generated, supplied with distributed that you can connect to zOS and send messages in. And there's also the MSOP MQ Explorer support pack also allows you to generate them. So penultimate topic, what are the apps doing? So this is an area where actually MQ on distributed does have better capabilities. It's got this idea of application activity trace that allows you to see in detail and in order what an application is doing, i.e. it opens this queue, it puts 2 messages, it closes the queue, it opens another queue and sends some messages, etc., etc. We don't have that on zOS. Again, feedback is useful. If that's something you want, then do let us know. But if you want to understand what the apps are doing, then really that accounting data I was talking about earlier is really the answer to that. And so the last thing I'm going to talk about is how about history? How can I look back in time? If something went wrong in the middle of the night when I was asleep, how do I understand what's going on and what was going on at that time? And there's obviously quite a few things you can do here, and some of them we've talked about already. If you've got SMF data being generated, statistics and accounting at that point, then that's obviously going to help you. You've got things like your monitoring solution, which hopefully would be generating alerts if queue builds up or channels stop running. We have error logs from the queue manager, from the applications, sometimes from the operating system itself. But actually, sometimes those aren't enough. What else is there? What other data points could you use? Many times they are enough, but what else is there? And here we actually have the MQ recovery log. So if you think about it, persistent messages being sent into MQ are logged. Okay, that means we write them down when they get sent, and also we write down information when they get destructively got. And that's done with MQ for zOS, regardless of whether they're in a transaction or not. And so that recovery log is updated by the queue manager in real time and kept for a fairly long period of time. So, there's a record of everything going on in your queue manager, probably for quite, for a number of days, quite easily weeks as well. So once you've got that data, why not mine it? And so we provide a utility that allows you to do that, and that's called CSQ1 log P. And it provides lots and lots of capabilities. Some of them are probably more useful from a development perspective, so I've used this a lot, this tool, but actually some of them are really useful if you're a customer. And what it will do is it will look at the active and the archive logs and allow you to extract information from them. So it is possible, if you know what you're doing, to go and see exactly when messages were put and when they were got and understand whether there was a rollback or not. It's also useful to understand and be able to pull out the message data, and that tends to be where it's useful to customers. Okay, and so CSQ1 log P is basically something you run via JCL, and there's a whole load of parameters you can pass in. So here is an example saying, I want you to go and pull out the data in one of my active logs, but it could easily be archives, and I want you to find all the data in this particular page set, starting at this particular point in the log. So page set 4 says everything on that page set. Extract means pull out the message data, and RBA start is basically the point in the log where you want to start looking for data. And then you have choice of what set of data you pull out. You can look at the committed data, you can look at the in-flight data, or you can look at backed out data. And that's what this CSQ commit thing, DD card is. That basically says, pull out the committed messages on my queue, so I can actually go and look at them and understand when they were sent and you know, what that data was, so I can do something with it. And this is the sort of output you get. It doesn't display particularly well in this sort of environment, but you can see that here we have a message, and the bold bit shows it's the message descriptor here, and in there there'll be a date and the time, and then I can see the message payload. Now, like I said, it doesn't display well here. However, we do provide tooling, which is this CSQ4 logs sample, which actually can be used with CSQ1 log P to go and actually do something with that output from the log. So it allows you to replay it to a target queue, which might be useful if your message data has been lost, or it might be useful if you want to generate data that allows you to kind of test your applications. But the key point is, this is a way of understanding what happened. You know, this message was sent some time ago. Now you can go and look at it again, understand where it's sent, and also using the various other attributes of CSQ1 log P, you can also understand you know, when it was got and all those other things. Although sometimes that requires a bit more of a conversation with IBM to figure out what's going on. So I've kind of been waffling for a while. Just to summarize, this is really about understanding, you know, the set of tools we have, and I hope you'll agree there's lots of tools in there. Maybe there's some you've not come across, but really, if you can't find your message, then we do have a way of helping you, and all these tools have been field tested for years now. So hopefully we'll allow you to understand what's going on and fix it. Now, I don't think I've seen any questions as I've gone along. So if anyone has any questions now, then feel free to stick them in the chat. And don't forget to fill out the survey. Where's that? Here it is. So this is for session 1AU. And also, if you don't want to talk now, then here you go. That's the slide I was looking for. Then my name's Matt Lemming. I'm more than happy to have an email conversation or a call if you've got any questions about any of the stuff you've heard today. So thank you for listening.
Thank you very much, Matt. And please leave feedback. Right, good. We have an accolade for you. The next MQ session is at 2 o'clock on MQ and high availability. And we have a third one today, a user presentation at 3:30 on a deep dive into MQ stats. So thank you very much for attending.
Thank you.
Thank you, and thank you, Matt.